Hi everyone, welcome to this week's tutorial. So I'm just going to go through, I hope you've all read the lecture notes on the hydrology and stormwater runoff. So we've gone through, we've looked at our water urban design, we've come through, calculated our flow rates, done our drainage layouts, and now we're going to go through and do the tutorial. Just want to bring your attention to our part area method example. I would highly recommend going through this example and making sense of it. So we briefly touched on this in the class. We're going to do a lot more questions on this. Please just go through, have a read through it, and make sense of it. All right. This here is really important for the rest of our assessments and for obviously understanding how our flow calculations work. All right, so I'm going to tackle question 2. Just for question 1, you've got to go through this example 6, and you're going to transfer all the data to a hydrological sheet here. All right, you've been given an example here, which is blurry as hell to look at. So in Learn, under lecture 11, download this here, this hydraulic design chart. So we went through this in the class, how to fill it out. Just start at pit 1 and then work your way from left to right and just answer these as we move along. So I'll let you tackle that. Alright, we're going to go through question 2. So we're looking at our figure 14 in the lecture notes. We're going to calculate the peak discharge to pit 10 and pit 5. We're going to assume a design AEP of 10% or an ARI of 10, grass footpath, and we're ignoring a bit of roadway upstream of pit 10. Alright, and we're also going to ignore bit discharge from pit 5 from pit 6. So let's go find this here. So we're looking at the last page in our notes. This is what we're looking at here. So I want to know the flow to pit 10 and the flow to pit 5, ignoring any flow that's traveling through here and ignoring any flow that's traveling back here. So to pit 10, I have my lot 5 is getting discharged straight from my stormwater outlet into the back of the pit. From that pit, we'll run down into pit 5. Pits 4, 3, 2 and 1 are all going to get discharged to the street water table and then run down that channel and be collected into that pit. We're also going to take some part of the roadway in here and then some part or all of the grass footpath through here. So that's what we need to look at. Now my pen that I usually write with has died. It's got a flat battery and it's a random size battery. So being a bit later on at night, I'm unable to get another battery for this pen. So we're going to tackle this in Excel. If we have any issues, I can go through it again by hand, but we'll see how we go with this. So the first thing we do whenever we have any question or any design, we always write down our variables or our knowns. So write down what we know. We pull the information out of our questions. So what do I know? Well, let's come back to my tutorial. So calculating peak discharge, cool. So design AEP of 10%. All right, easy. Let's have a look. So AEP is 10%, which gives me an ARI of 10 years. All right, what else do I know? Well, my lot sizes. So lots 1, 2, 3, 4, 5, 6, and 7. These are our lot sizes. So my area of my lots is equal to 20 times 30 meters squared. It's a 600 meter squared block, so quite big. Could divide them by 2, make a bit of coin. But okay, we're not going to worry about money at the moment. Let's worry about designing some stormwater. So what else do I have? Well, it's told that these lots are 50% roofed and paved. So it's 50-50 split. So that's going to help us later working out our pervious and impervious fractions. My road width, so road width 16 meters Alright, so from here to here, 16 meters. So half of it is 8, so from the crown to here is 8 meters. So a 4 meter traffic lane and a 4 meter footpath. So my footpath is 4 meters, and I'm going to say it's grassed. And my road lane is 4 meters, and obviously it's bitumen. Alright, location, Melbourne. We can go 50% roofed. Actually, we probably don't need to write that, we can just remember that for later. So, they're my variables that I can pull out. Let's go pit 10. Alright, so what do I know for pit 10? Alright, all I know is that lot 5 discharges to pit 10. That's all I really know here. So I need to go through, I need to find out some things for lot 5. Now, my CW, so we can go through and calculate CW because we've got 50% roofed and paved, so it's a 50-50 split. So 50% impervious, 50% pervious. But if you do that, it's not going to line up with the solutions that have been written out for you. So the other way we can do it, and the way that we're going to do it, is on page 24. Alright, so if you've got any information, we can use the CW of 0.45 with a TI of 5 minutes. So we're going to go through and do that. You could use 0.5, or you can come through and check it out here. But for us, I'm going to take 0.45 for this example. So CW 0.45, my I, or my TI, sorry, is 5 min. So if I'm aware of that, what else do I know? I know I need to go through, I need to calculate my 10I5. So remember, what if I can write in here? So 10I5, so AEP, I, and then my TC or my TI. So what I need to do is I need to go through and work out my I. Let's go have a look. It's going to be, remember, we are here with Melbourne. So looking at my IFD charts, Adelaide, Melbourne. It's coming across for 5 minutes, an AEP of 10%. I have 9.3 millimeters. So that's how much arrives in 5 minutes. So my intensity, I, is equal to 9.3, alright, times by, I need to convert it to be in millimeters per hour, so times by 60 to get it to hours, divided by 5 because I took a TI of 5 minutes. So that is 111.6 millimeters per hour. Alright, you can round that up to 112. So what else do I know? Q is equal to CIA divided by 3600, and that ends up in liters per second. So Q is equal to equals C times I times A divided by 3600, 8.37 liters per second. Alright, or 8.4 liters per second. So there is my first Q. Alright, so that is my peak discharge from lot 5 running to pit 10. Beautiful. So pit 10 taken care of. Let's bring this over a little bit. So now, if I was you, I'd write down underneath it, pit 5. I'm going to start over here, just so I can see them all on the same page. Pit 5. So, what do we have coming to pit 5? Well, I know that for my longest TC, my longest time to get to pit 5 is from the corner of lot 4. So for the time that it takes for a bit of rain to land back here, move down the block, come out into the channel, move down, by the time that happens, lots 1, 2 and 3 all would have discharged before then. Alright, so what I'm going to do is effectively I can ignore the overland flow time and use the weighted coefficient that I've looked at before, the 0.45, and I can use the TI of 5 minutes, because from the roof to the street running down this channel, it's going to take up to 5 minutes. Alright, so for lot 4 to come out, 5 minutes, down the channel we'll look at in just a minute, sorry. So let's have a look first at our roadway. So looking at my roadway, what I need to look at really is my channel time. This is what I'm trying to find. Now, how am I going to work out my channel time? Well, what I can see is from this point here, so I've got some spot elevations sitting in here. So I know from the pit to lot 4, 35.04 and 33.65. So for me to work out my fall, so I can go my elevation difference. Is simply equal to, where are we, 35.04, subtract 33.65. So 1.39 meters. That is the difference in elevation between pit 5 and the stormwater outlet at pit 4. So what I need to do is I need to now work out my distance to work out my slope. So to work out my slope, I need to know how far this is away. Now I've got 1, 2, 3, 4 lots. I've got 20 meter boundaries. I can take 80 meters. Now the issue with taking 80 meters is it's going to get us to this boundary here. So it's not quite true, because I do have a little bit more here. So it might be 15 here, 20, 20, and then another 3 meters or so, just looking per scale. So what I'm going to do is I'm going to take 60 meters. So distance, 60 meters. Now your solutions to this will go through and take 80 meters, take the fall there, and then calculate it for 60 meters and work out the difference between the two. You can do that, but what we're going to find is we're going to make some assumptions here as we tackle through. So my distance is 60 meters, which gives me a slope of equal to u divided by u. So the height divided by the distance. Alright, so that there, if I want to put it into a percentage, I'll come through, multiply it by 100, gets me a percentage slope. So 2.31%, so not overly steep, but steep enough. Now, how do I work out my channel time? Just like I said, I know my TI to this point here is 5 minutes. I need to work out how long it's going to take to travel down there. So let's come through, let's have a look in our appendix, see if we've got anything that's going to help us. So this one here, this might help. Fall of channel, flow time in channel, the flow distance. Beautiful, so let's use this. So my fall of my channel was 1.39, which is about here somewhere. My slope is about here. So you can come up and you can take whatever that number is, which is probably 0.9 of a minute, so 50 seconds. I'm going to take 1 minute just because it makes my life easier for calculations. It's not the end of the world to use it. So I'll take 1 minute. So my channel time is 1 minute. Very important to reference where you get these from. So that is figure, is it a figure or is it appendix? So figure 5.4. So next to our calcs, whenever I grab something like this, we always reference where it's come from. So I've worked out that. So now what I know is my channel time. So for the water to get from the discharge line to pit 5 is 1 minute. My TI is 5 minutes. So for the water to come to the street. So therefore my total time is equal to 5 plus 1 is 6 minutes. Okay, so that there is my total time for the pit, for lot 4 to arrive to pit 5. So what can I do? Well, if I have a look now, let's have a look. We'll chop and change a bit. So let's have a look here now at my residence. And this will make sense to why I'm going to do it like this in a minute. Basically what I'm going to do is I'm going to work out my CA for my lots and for my roadway, and then combine them together after. It just makes my life a little bit easier. So for my lots, or for my residential lots, what do I know? Well, my area is still the same. So my area, area is equal to 1, 2, 3, 4. I have 4 of them. So 4 times by, each of these is 600 square meters. So I have 2,400 square meters of land in here. So that's the area that we're looking at. My CW is still equal to 0.45, going from the assumptions that we make. So you can take 0.5, you get slightly different answers, but still correct. Probably a bit more conservative as well, which is good. So what I know is if I go CA is equal to U times by U, 10,080. Now, coefficients are unitless, so this is still meters squared. All right. So now let's have a look again. Let's come back to this. My roadway. So what I'm going to look at now is, remember my total time is still 6 minutes. I need to come through, and what I'm trying to work out now is my grassed area for the footpath, what's happening through here. So this is for my grassed footpath. Actually, let's not write that there because we'll split it up and use the roadway as well. So my road, if we remember, is 8 meters from here to here. So 4 meters and 4 meters. So it's an even split. So what that means, if it's an even split, I have 50% or 4 meters. For that area, my C10 value is 0.1 for the grass footpath. 50% or 4 meters of my C10 value for my actual road, the bitumen road that we drive on, I have a C10 value of 0.9. So we can go through and we can work out our weighted average, or our C part. So C part is equal to my 4 divided by 8, which is my road. My road is 4 meters. So my road here is 4 meters divided by 8, which is at half, times by my road coefficient, plus 4 divided by 8. So 4 meters is my footpath, so my grass footpath. 8 meters gets me from the crown to the edge. So again, road, footpath, and times by this coefficient, which is 0.1. So my C part is 0.5. All right, let's just write over here, 4 meter street or lane, 4 meter grass footpath. So what else do I know? Well, I need to work out an area here. So from these boundaries, I've got 1, 2, 3, 4. So going by the distances between my stormwater outlets being 20 meters each, because it's a safe assumption to go, okay, they're probably located in the same spot on each block. Their frontages are all 20 meters, so 20, 40, 60, 80. So I can take 80 meters through there. So my area, my roadway, is equal to the width of the road, which is this plus this, times by the distance, so from here to here, times by the distance from here to here, times 80, 640 meters squared. Also equals, just in case you want to go through hectares, you can use that as well. So once we've done that, what we need to go through is basically work out again a CA value for our roadway. So CA is going to be equal to 0.5 times by our area, 320 meters squared. So this effectively is our contributing area to flow. All right, so we go through, we go, okay, how much is this actually going to contribute to discharging our water to our street? So how much is going to get absorbed, how much is going to run off? And that's why we see this reduction here. So now that I've done these, I've worked out my CA coefficient, sorry, my C coefficient in my area for my roadway. Worked it out now for my residential lots that are contributing to the flow to pit 5. So now what I'm going to do is combine them. So let's go combined lots and roadway. The other thing you could do is you could punch this straight in now for Q is CIA for this one, Q is CIA for this one, and add them together. That will work as well. So I will show you Q is equal to, we've got to work out our I, so I'll do that one in a minute. All right, so let's go through. What I know is my CA total is equal to my roadway plus my lots, my TI, 6 minutes. What else do I know? Once I've done that, I need to calculate my I. So my intensity. So for 6 minutes, I know I won't have a number or an intensity associated with 6 minutes. I know what I'm going to have is I'll have a TI or an intensity. Intensity 5 minutes. I'm going to have an intensity of 10 minutes. Let's write that there. So this one here would be 10I5 and 10I10. That's in minutes. That's in minutes. So let's have a look and let's see what this intensity gives us. So look at Melbourne. So for 5 minutes, that's Adelaide, Nathan. So for 5 minutes, 9.3, and for 10 minutes, I'm getting 14.1. So 9.3 millimeters, 14.1, that's in millimeters. Convert these here to millimeters per hour is equal to this times by 60 divided by divided by 5, and that's in millimeters per hour. Beautiful. So now to work out my intensity for 6 minutes, millimeters per hour. I need to interpolate between the two. So I hope you all remember your interpolation formula. So it's equal to this one, subtract. Now I have to remember it as well. Where are we? 6 subtract this, stepping over our next step. We then multiply that by which step was it? This one, subtract this one, bracket, divided by this, subtract that. Right, I reckon that's it from memory, and that is what we get. So that's using linear interpolation. And what I end up with is an intensity of 106.2 millimeters per hour. Beautiful. So what I need to do now is work out my Q. Is equal to CIA divided by 3600, or 0.36 if you're going to use it in hectares. So Q is equal to, well, where is my C? C is C total. So CA, so I've taken into account C and A. So all I need to do is multiply it by my I, divide it by 3600, and that is my Q in liters per second. Just to show you here, Q is equal to this times this. Let's punch it here. Q equal to this. Alright, so if I want to check Q, so if I did them individually, wouldn't be an issue. All right, I end up with the same numbers. Yep, L on D, well done. L on S. So liters per second. So it's up to you as which one you want to do. Either combine them or do them individually. I don't care, same thing. All right, so what we can see here is the peak discharge to pit 5. So this one here is my peak discharge to pit 5. All right, so what that does is takes into account pretty much everything. All right, so we've got lots 1, 2, 3, and 4 running in here. Any of the flow from here. We also need to add in our flow from pit 10. So that's from all the lots. So my Q total is this plus what I found before running from pit 10. That's liters per second. And that is peak or total discharge pit 5. Alright, so that is how we tackle question 2. That's all sorted. Thank you. I hope that made sense. Any issues, please give me a call, flick me an email, and we can go through how to do it. And if we need to do it by hand, we can as well. So just remember the way we set calcs out. We set up our variables, and then we go through our logical steps. The other thing that we would put in here is any assumptions that we make. So if you want to make the assumption, so we've made the assumption here, so I can write it next to it as assumed, or I can just move all of this up into my variables straight away. So I've gone through, calculated flow to pit 10, then worked out my flow to pit 5, looked at my lots, looked at my roadway, combine them together, and then I've added in, because what we can see is it's all falling downhill. So the water from resident 5 moves to pit 10, moves down that pipe in there. And then obviously all of the water collected here in lots 1 to 4 moves to the water table, moves down the channel, and into pit 5. So it's a conservative way to go about it, but it's an effective way to go about it. So thank you all, and I'll see you next time.